Hello students, welcome you all. In my today's lecture, I will explain you the analysis of cycloaddition reaction by Woodward-Hoffmann method and by Huckel-Mobius method, or it is also called as the PMO method, perturbation molecular orbital method. In my previous lecture, I analyzed the cycloaddition reaction by orbital symmetry correlation method, or we can say by correlation diagram method. So I have already given the lectures on the analysis of electrocyclic reactions by these methods. Now, so first of all, I will discuss the Woodward-Hoffmann method or Woodward-Hoffmann rule. So according to this Woodward-Hoffmann rule, so what this rule says, so what we have to prove? For cycloaddition reaction, we have to prove the selection rule. We have to analyze this selection rule. For 4n electron system, it may be cycloaddition reaction may be the 4n electron system, or it may be 4n plus 2 electron system. In thermal condition, we can analyze a photochemical condition. So, in thermal condition, what we have seen, for 4n electron system, the two components interact in a suprafacial interfacial manner or intrafacial suprafacial manner. Whereas for photochemical condition, the two components interact in a suprafacial manner. Whereas for 4n plus 2 electron system, under thermal condition, they interact in a suprafacial manner. Under photochemical condition, the two components interact in a suprafacial intrafacial or interfacial suprafacial manner. So this is the selection rule that we have to analyze by using this Woodward-Hoffmann rule. So what this rule says, now when either under thermal condition reaction may be allowed, or under photochemical condition reaction may be allowed. Now out of these two conditions, no doubt suprafacial manner, the interaction in suprafacial manner is favored over the suprafacial intrafacial or interfacial suprafacial manner. So if according to this rule, the system is we can write the system is thermally allowed when the sum of two components, that is 4q plus 2s, this is one of the component, and 4ra, the sum of these two components, if we add the sum of these, the value of these two components, okay, then if comes out to be odd, then it is thermally allowed. And when the system is photochemically allowed, under what condition the system is photochemically allowed? When the sum of these two components, they comes out to be even. So 4q plus 2s and 4ra, when this comes out to be, the sum of these two components comes out to be even, then it is photo, or we can write this component, sum of these two components comes out to be even, then it is photochemically allowed. So we have two type of system, either 4n electron system, 4n plus 2 electron system. Now if you take the example of 4n electron system, where 2 plus 2 addition, that is 2 plus 2 cycloaddition reaction, 2 plus 2 cycloaddition. Okay, so if you will see here, then 2 plus 2 cycloaddition reaction, simplest example is when 2 ethene and these two ethylene system, they react and it is giving you this one. So this is the simplest example. So the lobes of these two that will interact. So we should not take for this rule, we have to take simply plus 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 plus, all plus plus like this. First ethene system, second one. This should also be taken as plus plus. We should not take the HOMO or LUMO like the FMO method. Okay, we should not follow here the FOMO method. We are not concerned with the HOMO or LUMO. So simply we take the plus 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 plus. And let's see one. Suppose they are interacting in this way. No doubt superficial interaction is favored. So when this superficial interaction is favored, so let us see. So what kind of this component now it become? Because they are adding in a S manner. So in my previous lecture I told you what is the meaning of this S and A. I told you what is the meaning of S and A. So if anything which is interacting here, if same side lobe is interacting, then this is S component. If different side lobe is interacting, then this is A component. This is our A component. This is A. What about 4Q plus 2S and 4RA? So when suppose if Q comes to be, if Q is 1, 0, 1, 2 like this, then such component is said to be 4Q plus 2 component. This is 4Q plus 2 component. When Q comes out to be 0, 1, 2, and when R comes out to be 1, 2, 3 like this, then this is said to be 4R component. So two type of component here. One is 4Q plus 2 component and another is 4R component. Now, what about this? Whether this is 4Q plus 2 or 4R? So if you will see, if you put Q is equal to, suppose I am putting Q is equal to 0, then we get 2 electron, 2 component. So this is 2 electron, that's why this is 4Q plus, this is 4Q plus 2. Now 4Q plus 2, whether this is S or A, this is because same side lobe is interacting, this is S. Same for this one, because same side lobe, this is also 4Q plus 2, S. This is also S. Now we should see whether this is thermally allowed or photochemically allowed. Whether this is thermally allowed, photochemically allowed, we should see the sum of these two components. Okay, let us see the sum of these two components. Now in this case, 4Q plus 2S. How many such components are there in this interaction? 2 components. So in this interaction, 2 such components are there. Now 4RA. How many 4RA component is there? No 4RA component. So 4RA, this is equal to 0. So this comes out to be total 2. So this is coming to be even. So if this is even, it means such interaction for 2 plus 2 cycloaddition reaction, such interaction is allowed photochemically only. So this means this is what kind of interaction this is? This is 2S plus 2S interaction. That is superficial interaction. So that's why it is photochemically allowed. It is photochemically allowed. Okay. Now, so now for 4n plus 2 electron system, if you see for 4n plus 2 electron system, let's check for this one. So this is case A for 4n electron system. This is case B for 4n plus 2 electron system. Now for this one, that is 4, that is you can say this is 4n, and that is it is 4 plus 2 cycloaddition reaction. This should be 4 plus 2 cycloaddition reaction. Okay, this is 4 plus 4n plus 2 cycloaddition reaction. The simplest example, when this butadiene it will interact with the ethene and you get the cyclohexene. Okay. Now, so how we will see? Now we should draw the terminal lobe for this one and terminal lobe for ethene. So terminal lobe for this butadiene plus, we are only concerned with this one, and terminal lobe for this ethene plus, minus. Now when this superficial interaction is allowed, let us see. So here these are interacting in what kind of manner? 4s plus 2s manner. Okay, this component is 4s, this component is 2s. That's why I have written 4s plus 2s, because this is interacting in a suprafacial manner. Same side lobe is interacting. Here also same side lobe is interacting. That is in suprafacial manner. That's what is 2s. Now what kind of component this is? Either this one or this one. Now, so if this is how many electrons are present over here? 4 electrons are present. So if we put R is equal to 2, then we get the 4R component. So this is 4R, and as they are interacting in a suprafacial manner, that's what is 4RS component. What about this? What about this? How many electrons are present over here? The electron present is 2 electrons are present over here, and this is interacting in a suprafacial manner. So 2 electrons means 2 electron. When the 2 electron come? When Q is equal to 0. When Q is equal to 0, then it means this is 4Q plus 2 and S. This is 4Q plus 2. Why S? Because they are interacting in a suprafacial. S. Same side lobe is interacting. That's what is 4Q plus 2S. Okay. Now, so let us see their sum. Let us see whether this is thermally allowed or this is photochemical error. For this, we should follow this rule. Now, 4Q plus 2S. How many 4Q plus 2S component are there? How many 4Q plus 2S component is there? Only one 4Q plus 2S component is there. How many 4RA component is there? 4RA component. So if you will see, there is no 4RA component. This is 4S component. So that's why 4RA component is 0 and is coming out to be 1, and this 1 is odd. So if 1 is odd, then it means it is coming odd. That is, this is thermally allowed. So for 4n plus 2 electron system, 4n plus 2 electron system, if the orbitals are interacting in suprafacial manner, then they will interact under the thermal condition. So therefore, it is thermally allowed. Okay. So this is about the Woodward-Hoffmann rule. So you may also go to the Woodward-Hoffmann rule for the electrocyclic reaction, and in the same manner you may see the analysis of this rule. In the same manner we can analyze. Only the rule was different for this. Okay, here this rule tells that 4Q plus 2S and this is odd. So according to that one, in electrocyclic reaction what we read is 4Q plus 2S, this if it come to be odd, then this is thermally allowed, and if 4Q plus 2A and 4RS, if this comes out to be odd, then this was photochemically allowed. So slight change in rule was there in case of electrocyclic reaction. Now let us see the analysis of cycloaddition reaction by Huckel-Mobius method. Okay, so according to this Huckel-Mobius method, so what this Huckel-Mobius method tells, it tells whether the node is present in a system or not. Suppose if there is no node, according to this rule, if no node is present, in that case the system is Huckel system. The system is said to be Huckel system or Huckel array system, we can say. So in this Huckel system is Huckel system, and suppose if 4n plus 2 electron is present, then system is aromatic. Aromatic means No doubt the aromatic systems are stable, and they are stable only under the thermal condition. This is thermally allowed. Okay. Now, suppose in Huckel system, if 4 n electrons are present, okay, we have already read the Huckel rule, and if 4 n electrons are present, that is said to be anti-aromatic. Anti-aromatic. If it is anti-aromatic, means system is unstable. Unstable, when it is unstable, when one of the electron go into the excited state, that is the photochemical allowed. In that case, it means this is photochemically allowed. Okay, so this is the case when no node is present, and such system is called as the Huckel system. Suppose if node is present, okay, then such system is called as the Mobius system, or Mobius array, Mobius system. Now in this case, suppose if 4n plus 2 electrons are present in the system, in Mobius system, suppose 4n plus 2 electrons are present, then such system is anti-aromatic. It is just opposite to this one. It is said to be anti-aromatic. Anti-aromatic means it is always unstable. Anti-aromatic system are unstable, we know. And when it would be an unstable, when one of the electron will get excited from its ground state to the excited state, and it get excited only in photochemical condition, it goes from ground to the excited state. And for 4n electron, such system, if node is present, that is Mobius system, and in 4n electrons are present, then it is aromatic, and aromatic system, and it is aromatic means stable. Stable means the electrons are present in the ground state, that is thermally allowed. Thermal. So this is about the rule. So this is the Huckel-Mobius rule. Now, so we may check for the cycloaddition reaction the selection rule. As I have seen, we have to check the selection rule for the cycloaddition reaction. Now first of all, we should see for 2 plus 2 cycloaddition reaction. For 2 plus 2 cycloaddition reaction, suppose we should see whether node is present or not. So this is 2 plus 2 cycloaddition reaction. So plus, plus, minus, minus, plus, plus, minus, minus. Like this, we should take the sign like this. Now, this one, it may interact in this way. Okay. So here you will find no node, because plus plus interaction gives no node, plus minus interaction gives node, so no node is present over here. If there is no node, it means the interaction, it means this is a Huckel system. This is Huckel system. If no node is present, it is Huckel system. And now in Huckel system, how many electrons are present over here? How many electrons are? This is 2 electrons. This is overall, this is 4 electron system. It is 4 electrons are present. It means this is 4n electron system. If it is 4n electron system, 4n electron means this is anti-aromatic. This is anti-aromatic. Anti-aromatic means this is unstable. Unstable means this is photochemically allowed. This is photochemically allowed. So we have seen the for 2 plus 2 cycloaddition reaction. For 2 plus 2 cycloaddition reaction, under photochemical conditions, suprafacial interaction takes place. Now suppose if you take the suprafacial intrafacial interaction. Suppose the interaction is like this, and suppose during the interaction you find one of the node. So how? Suppose this is like this, interacting in this way, and this is interacting with this opposite lobe, that is minus lobe. So you can see this plus is now combining with minus. So in this case, you will find one node. So node is present over here. So if node is present, then system is Mobius one. System is Mobius, and no doubt this is also 4n electron system. And Mobius system having 4n electron, this is aromatic, and aromatic means this is thermally allowed. So same rule that I told you. So rule was, what was the rule? Rule was, this was the rule for 4n electron, thermally allowed, photochemically allowed. Thermally allowed, when it was thermally allowed? When suprafacial, intrafacial, or intrafacial, suprafacial. Photochemically allowed, suprafacial. So this I have proved. So under photochemical condition, what kind of interaction? For suprafacial, suprafacial. So this interaction is 2s plus 2s. That is suprafacial, superficial interaction. Under thermal condition, what we have proved? It is suprafacial, intrafacial interaction will take place. That is, this is 2s, and this is interacting, the opposite lobes are interacting, that's why it is 2a. Okay, so this is for 2 plus 2 cycloaddition reaction. In the same way, we may prove for 4 plus 2 cycloaddition reaction. Now 4 plus 2 cycloaddition reaction, that is butadiene and ethene system. So let us see. Suppose this is butadiene, positive, negative. We are only concerned with the end orbitals. We are not concerned with the middle orbitals, because only end orbitals takes part in this reaction here. So here this is your ethene system. Here also plus, plus, minus. These are the end orbital of the, this is dienophile, this is diene, this is dienophile. Now it may interact either, this is one of the interaction, or this may interact in a suprafacial, intrafacial manner. Second type of interaction. So like this may interact in this way. So this will interact like this. So what kind of interaction? This is, what kind of interaction you can write? This is 4s and this is 2s. Same side lobe, same side lobe. So that's why it is 4s plus 2s interaction. What about this? What kind of interaction this is? You can write this is 4s for butadiene and 2a for ethene system. Okay. Now we should see whether this is thermally allowed or photochemically allowed. So we can see now. So this contains no node. No node. If no node, it means what type of system this is? This is Huckel system. This is the Huckel system. And Huckel system having the, how many electrons are involved in this system? 6 electrons are involved. So if 6 electrons are involved, it means it is 4n plus 2 electron system. And Huckel system having 4n plus 2 electron system, they are aromatic. Aromatic means stable. Stable means they are thermally allowed. They are thermally allowed. So what, same thing I have written in 4n plus 2 electron system. 4n plus 2 electron systems under thermal condition. What kind of interaction? Under thermal condition, suprafacial interaction takes place. Okay. Now if you will see here, then this is no node, here no node, but here one of the node is there. When suprafacial intrafacial interaction, during suprafacial intrafacial interaction, node is present. And if node is present, it means it is Mobius system. And if it is Mobius system, then that is, and it is 4n plus 2 electron system. And 4n plus Mobius system, which is having 4n plus 2 electrons, they are anti-aromatic and unstable and photochemically allowed. So this is anti-aromatic and thus photochemically allowed. H nu allowed. Okay, like this we can prove the selection rule for cycloaddition reaction by Woodward-Huffman rule and Huckel-Mobius rule. In my next lecture